Hey, what's up guys, Neven here from nevenmasters.com, and today I'm going to show you behind the scenes video of the car accident project. But first, let's remind ourselves how the project looked like. As you remember, a pretty funny and fun little non-animation. Now, why did I say this is a non-animation in the description of this project? Because this digital experience is not animated, it's actually programmed. So how would animation look like? So you would draw this van and the driver, and then you would move it here, and etc, etc. You would move this one frame by frame, and in that way you would animate an image, right? You would make an animation. But this is not how things work in Etoys. In Etoys you can program, actually code these drawings. So for example, we can draw this car, and then we see all the parameters and his attributes. So for example, every object has its x and y coordinates in Etoys. What does that mean? It means that if we move it around, we can see that the x and y coordinates are moving. Obviously, because x and y coordinates tell us where the object is in space. And what will happen if we, for example, increase its x coordinate over time? If we increase it, the car will move to the right. If we decrease it, the car will move to the left. Likewise with the y coordinates. If we increase y, it goes up, and if we decrease it, it goes down. And how will we use that knowledge to animate the car? I mean, obviously we will not have this menu here and then use this to move the car, right? We need to do it automatically. Well, we will do it by coding. We will make a script called drive, and that script will do the following. It will increase the car's x by 10 and the driver's x by 10 every frame of the script, and thus it will move the car and the driver, as you can see here. But what does this block of code do? Well, if we remove it, now the car will not crash, it will just drive away. So it seems that this part of the script makes the car crash. How does it do it? Well, it tests if the car's black color touches another black color, then it will make the crash sound, it will stop this script, and it will start the script fly, for the driver to fly away from the car. So why do we need to stop the drive script when the car crashes? Well, if we don't do it, the car will crash and then it will just keep moving, right? So we need to stop the car from moving when it crashes, and that's exactly what this command does. And then we start the driver's fly script. What does the fly script do? Well, as you could saw, it obviously makes the driver go in this direction by increasing its x coordinate for him to move to the right and increasing his y coordinate for him to move up. And the result of that action will be he will move diagonally to the right. And he also crashes, right? If we don't implement this, if we don't have this code, then the driver will just fly away from the screen. We obviously also want for the driver to crash by checking whether his black color touched a yellow color of this lamp. If that happens, we will make a laughing sound, as you remember from the animation. We will stop his flying, because if we don't, he will just continue to fly. We show blood, and the lamppost will fall down. Here we start the falling down script. And what does the fall down script do? Well, it obviously rotates the lamppost by 5 degrees every frame, so it will fall down. It will stick the driver to the pole. If we don't have this, then the driver will just stand in the air. But when the lamppost reaches around 95 degrees, it will make a sound and it will stop rotating. If we don't have this, then the driver and the pole will just rotate indefinitely. But let's now explain how exactly this command works. But first, I will show the difference between the new version and the old version of the script that sticks the driver to the lamp. This is the new version that you've seen so far, and this is the old version. As you could see, this time the movement was kind of jerky, right? And it landed in a wrong way at the end. So what does those scripts do? Let's first analyze the old version. How did we implement for the driver to stick to the lamp? Because obviously if we don't do it, it will stay in the air. So we did it like this. We checked whether the driver is touching the yellow color of the lamp. If it does, we do nothing. But if the driver is not touching the yellow part of the lamp, then we will move the driver forward and rotate him a little bit. which obviously makes perfect sense, right? If the pole is rotating, then the driver needs to follow the pole by moving forward and by rotating a little bit. And in such a way, we kind of approximated that movement. But it's not really appealing to the eye to see that kind of jerking motion, right? So we had to improve that script, and I couldn't do it by myself. I had to ask my good old online friend and Etoys enthusiast, Jeremy Landry, to help me with that. And this is a shout out to him. He runs an Etoys Club magazine, which you should totally check out because he does awesome stuff in Etoys. The link will be somewhere on the screen and in the description box down below. But moving on, how did Jeremy help us improve the script that sticks the driver to the lamppost? He basically said that we need to write a new one which will not approximate the driver's position, but it will move the driver exactly where we need it each frame. And here it is. Let's explain step by step what the script does. In the lamp's fall down script, we turn the lamppost by 5 degrees to the right each frame, but we also do the following. We make the driver's x and y coordinates the same as the lamppost's x and y coordinates. Every object's x and y coordinates are actually the coordinates of its rotation center. For example, this is the rotation center of the car. The car rotates around it, and x and y coordinates position of the car's rotation center are the ones we see in the car's menu. If we change its coordinates to 0, 0, we see the car move to the bottom left corner, but we see its top right half sticking out, because that's what we get when we move his rotation center to those coordinates. The same thing happens with the lamp and the driver. Lamp's rotation center is right here, and we will move the driver's center to the same place. Then, we will make the driver's heading, or we can say angle, the same as the lamp's heading. This just means that we need to rotate the driver in the same direction as the lamp. Their headings are represented with a green arrow, and that arrow tells us where will the object go if we move it forward. Next, we move the driver forward by the size of the lamp's length, because we need the driver to be at the yellow part of the lamp. But we need to subtract 70 from that movement, otherwise the driver will end up here. Then we need to fix the rotation by rotating him to his original position, which means the driver will be somewhere around here. Which means we just need to move him back and up a little bit. And that's it! We have fixed the jerky movement. But why did we need to use drivers and lamps' x and y coordinates and their headings? We had to use those parameters because they're the only things that we know for sure about those objects. We don't know the location of the yellow part of the lamp, we only know the location of the lamp's rotation center and its heading. So we had to use the data that we know so that we could calculate the data we didn't know, the location and the heading of the driver. Whew! That was a lot to take in, right? So now you probably understand why Lorenzo said this was the most difficult technical problem he had to solve in his life. I hope you guys found this video fun and educational, and I hope I successfully demonstrated why Etoys is the best tool for teaching programming basics. Thanks for watching, and I'll see you guys next time!